In the summer of 1909, Maintenance Inspector Thomas Whitley filed a report that exposed Washington's most embarrassing operational crisis. The nation's legislators were chronically late to their own votes. His August 3rd documentation revealed senators sprinting through corridors, representatives abandoning dignity for speed, and a legislative process crippled by simple physics. The Capitol complex had sprawled beyond functionality, and democracy itself was being slowed by walking distance. The problem had reached critical mass. Senate and House office buildings stood hundreds of yards from the Capitol chambers. When votes were called, members had 15 minutes to traverse hallways, stairs, and plazas. Winter meant arriving snow-covered and breathless. Summer brought sweat-drenched suits, wilted by Washington's humidity. Close votes were missed, quorums delayed. Government machinery ground slower not from political gridlock, but from literal, physical gridlock in the marble corridors connecting power to its execution. The numbers told a story of organizational chaos. By 1912, the House of Representatives alone was conducting an average of 247 roll call votes per session. Each vote required 435 representatives to physically relocate from their offices to the chamber floor. Assuming even a conservative estimate of 10 minutes per transit, Congress was collectively burning through 1,825,000 minutes per session just walking to votes. That translated to roughly 30,417 hours, or 1,267 days of combined human time spent in transit. For an institution supposedly governing the world's emerging superpower, it was an absurd waste of the nation's most valuable political resource, the time of its elected officials. The Senate faced similar mathematics, though with smaller numbers and arguably higher stakes. Senators, representing entire states and wielding disproportionate power in the constitutional framework, were spending significant portions of their working lives simply getting from point A to point B within a government complex that sprawled across multiple acres. Foreign diplomats and visiting dignitaries found the spectacle puzzling. The British Parliament, the French Assembly, the German Reichstag, none of these comparable institutions required their legislators to maintain the fitness levels of cross-country athletes merely to participate in governance. Yet here was the United States Capitol, supposedly the temple of modern democracy, operating with the logistical efficiency of a medieval castle town. What made the situation particularly maddening was that solutions existed elsewhere. Department stores in New York had installed pneumatic tube systems for moving documents. Hotels in Chicago featured passenger elevators that had become architectural marvels in their own right. Underground railways were transforming urban transportation in London, Paris, Boston, and New York. The technology for rapid transit existed. The engineering knowledge was available. What was lacking was the political will to apply modern solutions to Congress's antiquated operational framework. Elliott Woods held one of Washington's most thankless positions, architect of the Capitol. Appointed in 1902, Woods was responsible for maintaining and improving the physical infrastructure of the legislative branch while navigating the treacherous waters of congressional politics. Every decision required committee approval. Every expenditure invited scrutiny. Every innovation risked becoming a political football between parties or chambers. Woods understood that proposing a subway system beneath the Capitol would require more than engineering expertise. It would require political theater. The breakthrough came through strategic patience and careful coalition building. Woods began documenting the transit problem with scientific precision, creating detailed logs of missed votes, delayed proceedings, and time lost to pedestrian congestion. He commissioned studies comparing congressional efficiency to international legislative bodies. Most cleverly, he arranged for senators and representatives to experience demonstrations of underground transit systems in other cities, planting the seed that Washington was falling behind global standards of governmental modernization. By 1908, Woods had assembled enough political support to make his pitch: a small-scale underground railway connecting the Senate office building to the Capitol chamber, powered by electricity, operating continuously during session hours. The proposal met immediate resistance. Fiscal conservatives balked at the estimated cost of $150,000, a substantial sum in an era when the entire annual capital operating budget was under $2 million. Traditional senators viewed the idea as an unnecessary luxury, arguing that a brisk walk provided healthy exercise and reflection time. One senator famously declared that, "If our forefathers could walk to cast votes that founded this nation, surely we can manage a few hundred yards without mechanical assistance." Others feared the underground construction would damage the Capitol's historic foundation or create structural vulnerabilities. Woods faced the classic innovator's paradox. The system was obviously needed, but nobody wanted to be responsible for funding it. The political breakthrough arrived from an unexpected source: a snowstorm. On January 23, 1909, Washington experienced one of its most severe winter storms in decades. Snow accumulated at rates exceeding 2 inches per hour. Temperatures plummeted to single digits, and Congress had scheduled crucial votes on tariff legislation that couldn't be postponed. The result was exactly the disaster Woods had been warning about. Senators trudged through knee-deep snow, arriving frostbitten and delayed. Several elderly representatives were physically unable to make the journey and missed votes entirely. One congressman collapsed from exposure and required medical attention. The legislative session descended into chaos as quorum requirements couldn't be met and critical votes were postponed. The next morning's newspapers captured the debacle in merciless detail. Political cartoons depicted senators as Arctic explorers struggling across frozen wastes to reach the Capitol dome visible in the distance. Editorial writers questioned whether the world's richest nation could afford to subject its leaders to conditions that would embarrass a frontier outpost. International papers picked up the story, portraying American government as comically backwards. The embarrassment accomplished what Woods's careful documentation couldn't. It created political urgency. Within weeks, appropriations committees began fast-tracking funding discussions for the subway system. The final authorization came through a typically congressional compromise. The initial system would be limited to a single line connecting the Russell Senate office building to the Capitol. It would operate as a trial program, subject to review after 1 year. The budget was capped at $140,000, requiring Woods to find efficiencies in design and construction. But the project was approved. On March 4, 1909, President William Howard Taft signed the appropriations bill, and the Congressional subway moved from architectural fantasy to engineering reality. Construction began on May 17, 1909. Under conditions of unusual secrecy for a government project. Woods recognized that every delay, every cost overrun, every construction mishap would provide ammunition for critics hoping to see the project canceled. The work proceeded through a combination of cut-and-cover excavation and careful tunneling beneath the Capitol grounds. Engineers working on the project faced unique challenges. They were excavating beneath active government buildings that couldn't be disrupted. They were working around utility lines, foundations, and structural supports that predated accurate surveying. And they were doing all of this while Congress remained in session directly overhead. The technical specifications reflected Woods's cautious approach. The tunnel measured roughly 200 feet in length, running from the Russell Building's basement to a terminal beneath the Capitol's Senate wing. Track gauge was set at standard railroad dimensions of 4 feet 8.5 inches, ensuring compatibility with conventional rolling stock if needed. The tunnel itself was constructed with reinforced concrete walls and ceiling, designed to support not just the weight of the buildings above, but also the potential for future expansion. Electrical systems were installed for both motive power and lighting, using the latest 600-volt DC technology that was becoming standard in urban transit applications. The rolling stock presented its own engineering puzzle. Woods needed vehicles that could operate in an extremely short tunnel with minimal stopping distance, carry enough passengers to be useful, but not so many that evacuation would be dangerous in an emergency, and maintain the dignity expected in congressional facilities. The solution came through a Chicago manufacturer who had been building streetcars for urban transit systems. The first congressional subway car measured 18 feet in length, featured ornate wooden paneling and plush upholstered seating for 18 passengers, and was powered by electric motors capable of reaching speeds up to 18 miles per hour, though in practice, the short distance meant cars rarely exceeded 10 miles per hour. On April 13, 1912, almost 3 years after construction began, the Congressional subway carried its first official passengers. The delay from Woods's original timeline reflected the methodical care required for every aspect of the project. Safety systems had been tested and retested. Operators had been trained to handle both normal operations and emergency procedures. The terminal stations had been finished with marble floors, brass fixtures, and architectural details matching the grandeur of the Capitol itself. When Vice President James Sherman and a delegation of senators made that first journey, they traveled through what was essentially an underground palace. The initial reviews were rapturous. Senators who had been skeptical discovered that the 3-minute subway ride transformed their daily routine. What had been a 10 to 15-minute walk, subject to weather and physical stamina, became a brief, comfortable transit that consumed virtually no time from their schedules. The cars ran continuously during session hours, operated by attendants who quickly learned to recognize members and their staffs. The system's capacity handled peak loads during vote calls while maintaining an atmosphere of quiet efficiency during normal hours. Within weeks, the subway had become so integral to Senate operations that it was difficult to imagine how the chamber had functioned without it. The success metrics exceeded even Woods's optimistic projections. Missed votes due to transit delays dropped by 87% in the system's first year of operation. Session times shortened as quorum requirements could be met more rapidly. Elderly and disabled senators who had struggled with the walk found renewed ability to participate fully in floor proceedings. The cost-benefit analysis was undeniable. The $140,000 investment had purchased a permanent increase in legislative efficiency worth many times that amount in productive time reclaimed. Congressional critics who had opposed the project quietly shifted to demanding expansion to serve the House of Representatives. The House system followed 4 years later, opening in 1916 with a similar design but different operational challenges. Where senators numbered just 96 members operating with relatively genteel decorum, the House crammed 435 representatives into a larger but proportionally more chaotic chamber. The House subway required higher capacity, more frequent service, and terminals that could handle rush hour surges when votes were called. The engineering solution involved 2 parallel tracks, allowing cars to operate in both directions simultaneously, effectively doubling throughput compared to the single-track Senate system. The interwar years saw a steady expansion as new office buildings were added to the Capitol complex. The Longworth House office building, completed in 1933, received subway service almost immediately. The Rayburn House office building, finished in 1965, was designed from the ground up with subway integration as a core feature. By the 1970s, the Congressional subway system had grown to encompass multiple independent lines connecting 6 different buildings to the Capitol chambers, with a total track length exceeding 3/4 of a mile. What had begun as Elliott Woods's experimental 200-foot line had evolved into an intricate underground network, rivaling small city transit systems in complexity. Technical evolution kept pace with physical expansion. The original wooden cars with their plush upholstery gave way to more modern aluminum-bodied vehicles in the 1960s. These featured improved safety systems, air conditioning, and capacity for up to 30 passengers. The 1980s brought automated operation to certain lines, replacing human operators with computer-controlled systems that could maintain precise headways and respond to demand fluctuations. By the 1990s, the newest vehicles featured the kind of sleek, modern design one might expect in a corporate headquarters or high-end hotel, complete with digital displays showing vote schedules and legislative calendars. Yet throughout these modernizations, the core mission remained unchanged, moving legislators from offices to chambers with maximum speed and minimum disruption. The subway's success was measured not in ridership statistics or revenue per mile, but in a simpler metric: whether Congress could function efficiently. By that standard, the system had proven itself indispensable to American democracy. What most visitors to the Capitol never realize is that the subway system represents just the visible portion of a vast underground infrastructure supporting congressional operations. Beneath the marble halls and ornate chambers runs a network of tunnels, corridors, and service passages that would impress any urban planner. Some passages handle utilities: steam pipes for heating, chilled water for cooling, electrical conduits, fiber optic cables for communications. Others serve as secure pedestrian routes for staff who need to move documents, equipment, or themselves without using the public corridors above. The subway tunnels integrate into this larger subterranean ecosystem, sharing space with systems that keep the Capitol complex functioning. The security dimensions of this underground world became particularly salient after September 11, 2001. What had been a convenience for legislators suddenly became a critical evacuation route and secure transit corridor during emergencies. The tunnel system allowed for rapid, protected movement of congressional leadership during threats or attacks. New security protocols were implemented, including hardened doors that could seal off sections of the tunnel network, surveillance systems monitoring every passage, and air filtration capable of protecting against chemical or biological threats. The subway cars themselves were retrofitted with communications equipment, allowing leadership to remain connected to national security infrastructure even while underground. The operational logistics supporting the subway system reveal an organization managing complexity with remarkable efficiency. A dedicated maintenance staff works overnight shifts inspecting track, testing electrical systems, and ensuring the cars meet safety standards. The vehicles undergo daily cleaning and weekly deep maintenance. Track geometry is surveyed monthly to detect any settlement or deformation. The electrical systems include redundant power supplies, ensuring operation even during wider grid failures. All of this maintenance happens invisibly to the members who simply expect the system to work whenever they need it, much like they expect lights to illuminate when switches are flipped or water to flow when taps are opened. Over more than a century of operation, the Congressional subway has evolved from infrastructure into cultural institution. Generations of members have their first subway ride as newly elected representatives or senators, experiencing a ritual that connects them to predecessors stretching back to 1912. The cars become unofficial meeting spaces where deals are negotiated, alliances are formed, and political intelligence is traded during the brief transits between buildings. Veteran members develop preferences for specific cars or operators, small personal quirks that humanize the grand machinery of government. The subway also serves as great equalizer in an institution increasingly stratified by seniority and party leadership. A freshman representative shares the same car as the Speaker of the House, A junior senator rides alongside committee chairs who have served for decades. The subway's limited capacity and continuous operation make it difficult for leadership to monopolize access or create hierarchies of convenience. Everyone waits their turn. Everyone rides the same cars at the same speed. In this small way, the subway enforces a kind of democratic equality that the broader institution often struggles to maintain. Journalists and historians have documented countless significant moments occurring in subway cars. Legislation has been drafted on napkins during brief rides. Political scandals have broken when members were overheard discussing sensitive matters in supposedly private conversations. Bipartisan friendships have formed during regular encounters in the shared transit space. The Congressional Record and newspaper archives are full of references to subway diplomacy, the informal negotiations and relationship building that happens in these underground corridors removed from public view and media scrutiny. Today's congressional subway operates in a technological and cultural context Elliott Woods could never have imagined. Members carry smartphones providing instant communication with staff, constituents, and media. Video conferencing allows participation in meetings from remote locations. Electronic voting systems could theoretically allow members to cast votes from their offices without physically entering the chamber. The original problem the subway solved, the physical challenge of moving legislators to the chamber floor, has been rendered technically obsolete by digital technology. Yet the subway remains essential, and its continued necessity reveals something fundamental about how legislatures actually function. The constitutional requirement for in-person voting isn't merely traditional, it reflects a conviction that democratic decision-making requires physical presence, personal interaction, and the kind of spontaneous deliberation that only happens when people occupy the same space. The subway enables this physical co-presence without the friction that would make it impractical. It allows Congress to maintain its traditional operational culture while managing the geographical sprawl of a modern legislative complex. The system's annual ridership exceeds 200,000 trips, with peak usage during high-stakes legislative sessions when votes are frequent and time is precious. The operating cost, covered through the legislative branch appropriations, amounts to roughly $2 million annually when maintenance, staffing, and utilities are included. By any measure of cost-effectiveness, this represents extraordinary value. The equivalent in lost productivity from transit delays would far exceed the operational expense. The system pays for itself many times over simply by enabling Congress to function at the pace modern governance demands. Maintaining century-old infrastructure presents ongoing challenges as the oldest portions of the system approach their 115th year of continuous operation. The original Senate tunnel requires constant monitoring for structural integrity. Foundation settlement, water infiltration, and the natural degradation of concrete all threaten the tunnel's long-term viability. The architect of the Capitol's office has developed comprehensive preservation plans addressing these challenges, but implementation requires funding and coordination that can be difficult to secure in an era of tight budgets and competing priorities. The rolling stock faces similar preservation pressures. While the newest cars date from the 1990s and remain in excellent condition, the system also maintains several historic vehicles for ceremonial use and as operational backups. These include one of the original 1912 cars, painstakingly restored to its original condition, and several mid-century vehicles representing different eras of the system's evolution. Keeping these historic cars operational requires specialized expertise in antique electrical systems and custom fabrication of replacement parts for components no longer manufactured. The maintenance shop has become a repository of institutional knowledge about early 20th century electric railway technology. Future expansion remains under discussion. The Capitol Visitor Center, opened in 2008, could potentially benefit from subway connection. though the logistics of serving tourists while maintaining security for members poses significant challenges. Proposals for extending service to additional House office buildings surface periodically in appropriations discussions. More ambitiously, some have suggested connecting the Congressional subway to the broader Washington metro system, though the security implications make this unlikely. Each expansion proposal must balance operational utility against cost, security concerns, and the disruption inevitable in any construction project beneath active government facilities. On an average Wednesday afternoon in contemporary Washington, the Congressional subway operates with the quiet efficiency that has characterized it for over a century. Cars glide through tunnels on precise schedules. Members board and disembark with the casual familiarity of daily routine. Vote bells ring, and within minutes, hundreds of legislators are transported from their scattered offices to the chamber floors where democracy's work proceeds. The system has become so thoroughly integrated into congressional operations that its existence is taken for granted, the ultimate success for any infrastructure. Yet, the subway represents something more than mere transportation infrastructure. It embodies a particular vision of how democratic institutions should function. Efficiently, accessibly, with appropriate dignity, but without unnecessary pretension. The system's creation required political courage to overcome institutional inertia and fiscal conservatism. Its expansion demonstrated adaptability to changing needs. Its preservation reflects respect for institutional continuity. In these ways, the subway mirrors the larger congressional institution it serves, with all the messiness, compromise, and occasional moments of genuine innovation that characterize American democratic governance. The Congressional subway carries no tourists, generates no fare revenue, and exists solely to serve a few hundred elected officials and their staffs. It is, in the most literal sense, an exclusive transit system accessible only to the tiniest fraction of the American population. Yet, its impact extends far beyond its exclusive ridership. By enabling Congress to function more efficiently, the subway serves the entire nation. Every vote cast on time, every quorum achieved without delay, every legislative session that proceeds smoothly rather than grinding to a halt. These small efficiencies accumulate into real improvements in democratic governance. The trains running beneath Capitol Hill carry more than passengers. They carry the ongoing work of American democracy itself, moving forward through underground tunnels toward whatever challenges and opportunities the future holds.